Okay, hey guys, here is day 5 notes. Okay, this will be on derivatives of trig functions. So this is going to kind of incorporate everything we talked about last class, which was the chain rule, and then working that into trigonometry, which we've talked about a lot. So there's some things to remember, and we'll talk about that. We'll incorporate some previous stuff, and then there's really 5 examples. It should go by pretty quick. Okay, some things to remember. Okay. We've not done this before, but if I take the derivative of sine, that is cosine. If you take the derivative of cosine, that's negative sine, okay? Derivative of tan, that's secant squared x, which is really just secant of x squared. The derivative of cotan is negative cosecant squared. The derivative of secant is secant x times tan of x, which is a little interesting. And lastly, the derivative of cosecant is negative cosecant of x times cotan of x. Okay. So, real fun. These two are pretty easy to remember. Everything else you may need to draw back from, but just practice. It'll all get better over time, okay? So I'll keep that at the top there. Refer to that if you're ever looking for the derivatives of those things. But what I want to do real quick is go through these 5 examples, and then you guys can work on your homework and do your thing, okay? So first one, find the derivative of sine to the 4th power of x. So what we're going to redo is rewrite this as sine of x to the 4th, because that's what it is, okay? That'll make us do this a lot more easily. So in this situation, think of that chain rule we talked about. We have the outer stuff, something to the 4th power. That's your f. Your inside is your g of x. So when we take the derivative of this example, it's going to be the derivative of the outer part. So it'll be 4 times the sine of x to the 3rd power, right? Because we multiply in front, subtract 1 from the top. So that's the outer portion. And then we need to take the derivative of the inner part, which that will be cosine of x, okay? We know this because this is the derivative of sine of x. That we see up top. The derivative of sine is cosine. There's your final answer. So the chain rule, again, derivative of the outside times the derivative of the inside is this. Okay? Love it. Down here, find the derivative of f of x equals 4x cubed times cosine x. We have something times something. That means we need to use the product rule. Okay? If I take the derivative of f, we have the derivative, we have, how am I doing this? Okay, we have 4x to the 3rd, the f, times the derivative of the 2nd. So that will be times negative sine x. Okay. Then we have plus the 2nd piece, so the g, so that'll be like cosine of x, times the derivative of that front part, which will be 12x squared. Beautiful. So again, to cover over, it's the original part times the derivative of the 2nd plus the original 2nd part times the derivative of the 1st. There we go. Did the product rule. Life is good. Life is Gucci. We move on. For number 3, find the derivative of this. So now we're going to be working with the quotient rule. This one is the really nasty, really ugly one. If you guys would like, I could write that formula down because it's so boo-boo McGee. That's if I'm taking the derivative of, f of x over g of x, right? And I'm doing some work here. That's where I have g of x times the derivative of f minus f of x times the derivative of g all over g of x squared. That's the quotient rule, okay? And I want to apply that to this problem where f of x is on top and g of x is on the bottom, okay? So let's get that set up and let's see what we can do. So if I want to set up this problem, we have g of x, which is 7x squared plus 4x. So that's my g of x right over here. Okay. Then we're going to times that by the derivative of f. Okay. The derivative of tan, we know, is secant squared x. Okay. Boom. There's the first part. Okay. Then we're going to subtract f of x, which is tan of x, times the derivative of g of x. Okay, and the derivative of g of x is going to be 14x plus 4. Boom. All of that on top, and that's all over g of x squared. So that's the g of x stuff to the second power. So that's all over 7x squared plus 4x, all squared. There's that g of x, all squared. And all I did was use the quotient rule, okay? So I wrote that here to the side. If you want to look at it, I applied it there. Life is good, okay? Beautiful. Number 4, find the derivative of this awful looking, terrible, unbeautiful thing. Let's do it. So if we do, oh my gosh, we have like a, oh wow. We have a product and another product. Oh my gosh. Why do babies get sick? Okay, we have two products. So let's do the derivative here. This is going to be so much fun. Okay, for that first part, it's the beginning part times the derivative of the second part plus the second part times the derivative of the first part. So there's our first chunk right here. That's this this purple chunk, right? That's the derivative using the product rule. Oh, woof. Okay. And then the second part is going to be the beginning. So it's 2x times the derivative of cosine, which we know is negative sine of x. Okay. Then it's plus cosine of x times the derivative of 2x, which is 2. Beautiful. So this pink part goes with this part. And really, guys, it's just the product rule two separate times. So the product rule of the first part plus the product rule of the second part, because I had a plus in the middle. And luckily, this is gorgeous because some things cancel out. Sine of x times 2x and 2x times negative sine of x. Positives and negatives cancel out. And my derivative is going to be x squared cosine x plus 2 cosine x. They don't really combine. There's your answer, and life is beautiful, okay? That one is so much fun. And finally, oh, this one is just absolute horror, terrible, incredibly awful problem. We're going to take this bad boy. We're going to rewrite it, because remember, tan squared is really tan of whatever squared. So I'm going to rewrite it as tan of x squared, or sorry, x to the cube. Sorry, it looks so awful. And then all of that squared. So this one, this is just horrific. This is a chain of a chain of a chain of a chain. So this is a chain, chain, chain. Oh my gosh. Because there's the outside. Look at this. This is horrific. There's the outside stuff that's squared. Then there's the inside stuff, which is tan. And then there's the inside stuff, which is x cubed. This is horrible. So, oh, I just love this so much. This is so fun. f prime of x. So first we do the derivative of the outside stuff. This one's great. So it's 2 times the tan of x cubed. And then if you want to put a 1 here, we can. But we do that outer derivative. Multiply in front, subtract by 1. There's the outer derivative. Then, oh my gosh, we got to do the derivative of the inside part, which is derivative of tan. Derivative of tan is secant squared. So that's the derivative of the tan part, right? The derivative of that is secant squared of the inside. And then finally, we do the derivative of the inside part, which is 3x squared. So it was like chain of the outside, of the inside, and of the final middle. And there is your final answer. That is so freaking sweet. I love it. Life is beautiful. That's it. Life is good. Okay. Have a great Thursday, and I'll see you guys very soon. Let's see if I can finish it this time. Bye.